Hello students, how are you? Well, we have already done many things in the chemistry and today we are going to start with a portion of odd electrons. See, when I say odd electrons, this is the most difficult topic in chemical bonding in inorganic chemistry. What are the odd electrons? See, odd electrons are those species in which one electron always left as it is unpaired. For example, if I say, suppose I say nitrogen monoxide. Suppose if you want to draw the Lewis dot structure of nitrogen monoxide, what is the valence electrons in nitrogen? You already know. Nitrogen is having atomic number 7. That means 2, 5. And oxygen is having 8 electrons. That means 2, 6. So that means nitrogen is having 5 valence electrons and oxygen is having 6 valence electrons. So suppose I say that you have to draw the electron dot structure of nitrogen oxide. So what happens if you want to satisfy the octet of oxygen, then you will try to form only 2 bonds, means 1 and 2, means octet of oxygen is complete and nitrogen, it is having only 1 electron left as it is unpaired. This unpaired electron is basically called as odd electron. Its existence is obviously very difficult, but it exists. Now the problem is, suppose if you satisfy the octet of oxygen, then odd electron will like this only, and in oxygen you are having 8 electrons and in nitrogen you are having only 7 electrons. Now suppose if somebody says, no sir, I want to complete the octet of nitrogen. Suppose if you want to complete the octet of nitrogen, then you will try to form the bond. 3 bonds are there like this only, and then oxygen is having 6 electrons, 3 are forming bonds and 1 electron will left as it is. Now in this particular form, nitrogen is having 8 electrons but oxygen is having 9 electrons with this odd electron species. This is the lone pair, 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 and this is the odd electron. So this odd electron will come now in oxygen atom. The problem is that in these 2 electron dot structures, only one structure is correct. Why? I have already told you one VK alert. What is the VK alert? I have already told you that in modern periodic table, the second period elements. Second period is what? Boron, carbon, nitrogen, oxygen, fluorine, neon. The problem is that the second period elements is having no vacant d orbitals. If they are not having no vacant d orbitals, so definitely their maximum valence electrons should be 8, not more than 8. Means I have already told you that they will not show expansion of octet, means in their valence shell they are having maximum 8 electrons only. So now if this concept you already know through me, so which particular structure is correct, this one or this one? Actually in this particular structure, if you will see, oxygen is having 9 electrons, 1 2 3 bonds, means 6 electrons, 8 and 9. So this oxygen, it is having valence electrons 9. See, lower than 8 is possible, but more than 8 is not possible for these elements. Oxygen is also there, so it is not having vacant d orbitals, so definitely this structure is not correct. So only this structure is correct. That means in NO molecule the odd electron will come only over nitrogen. You cannot go through this particular structure. So definitely the odd electron is over nitrogen atom. Its hybridization tendency is totally different. Many other things are totally different. That I will tell you afterwards. Okay or not? So odd electrons basically you are having in NO, and I will give you some more examples. Now I will give you one homework that you have to draw the structure of NO2 and ClO2 also. These two molecules are also having odd electron systems. But here in chlorine, chlorine will lie down the fluorine. So chlorine will have vacant d orbitals. So definitely it may have more than 8 electrons. But nitrogen, oxygen, again you have to be very careful. Is it okay to you? Suppose I will say this you understand? Now I will go, chalo, I will tell you one more example like NO2. NO2, nitrogen dioxide. It's a very famous gas whose color is brown. So you have to remember this also. NO is colorless, but NO2 is very famous brown gas. It's very famous brown gas. So whenever I say brown gas, you will say that, okay, it is NO2. Now, again, nitrogen is having 5 electrons. So I put nitrogen 5 electrons like this, and one is this. Here I put oxygen. So here octet of oxygen is complete. Now octet of nitrogen is also complete because one bond is here, one bond is here, and one more is with this oxygen. Like this. Now if you will see that this octet, these two bonds are formed, that means oxygen is complete. This one bond is formed, nitrogen octet is complete, but oxygen is having one odd electron. How? You will see this. This is sigma, this is sigma, this is pi, this is lone pair, 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 but this is the odd electron. Now in this oxygen is having 8 electrons. 1, 2, 3, 4. 4 pairs means 8 electrons. Nitrogen is also having the 8 electrons. 1, 2, 3, yani 6 electrons, and that means these two again 8 electrons. But this oxygen is having 1 electron unpaired and unbalanced. So odd electron this. Now suppose somebody is saying you have completed the octet of this one, you have completed the octet of this one, and you left the octet of this one. Why not? I want that both oxygen octet will complete. So now if you want to draw one more structure where both oxygen atoms is having 8 electrons in it, means both oxygen will form 2 bonds, then what will happen? Let's see. Nitrogen is having 5 electrons, so 2 electrons here, 2 electrons here, and 1 odd electron is here. So see, I will form like this. Now this octet is complete. Now this octet is also complete. Now again I will go to this, but nitrogen I have to be a little bit doubt. Why? Because see, this is a lone pair. See, this is a lone pair. See, this is a lone pair. This is a lone pair, and this is the odd electron. Now, if you want to satisfy the octet of both oxygens, then the odd electron will come over nitrogen. Means one electron will always left as it is unpaired. So that is called odd electron. Now the problem is that is this structure is okay or this structure is okay? This structure is wrong. Why? Because now the nitrogen is having 9 electrons. You can count it easily. Valence electrons is how much? 9. So this structure is wrong. Nitrogen cannot have more than 8 electrons. Second period elements, boron, carbon, nitrogen, oxygen, chlorine, neon, they should have maximum 8 electrons valence. So that means this structure is correct. So definitely the hybridization of this particular form you have to find it out, and hybridization tendencies are totally different in this. It's a little bit difficult. So okay, I will tell you in a weaker concept manner. I hope so you understand that the exact structure of NO2 is this one, not this one, because it violates the octet rule tendency for second period elements. Is it okay to you? In the next video, I will tell you about ClO2 and hybridization tendencies in this one, which is quite different and which is very much important for the medical and engineering entrance examination. Thank you. Goodbye.